So far, we learned Riemann Zeta function, and we introduced Riemann Zeta as the summation of 1 divided by n to the x, and starts from 1, goes to infinity, which is the summation of 1 divided by 1 to the x, plus 1 over 2 to the x, plus 1 over 3 to the x, and so on. And it happens that the zeta of 2, which is the summation of 1 divided by n squared, is nothing but pi squared divided by 6. And please note that this is basically a p series. P is 2 more than 1, so you end up with a convergent series. We have another interesting case, zeta of 4. Zeta of 4, which is the summation of 1 divided by n to the 4th. N starts from 1, goes to infinity. This summation is equal to pi to the 4 over 90. So basically, if you add these terms, 1 divided by 1 to the 4, plus 1 divided by 2 to the 4, plus 1 divided by 3 to the 4, plus 1 divided by 4 to the 4, plus the rest of the terms is nothing but pi to the 4 divided by 90. We're going to use this sum and find other sums. In this question, I ask you, find the sum of the series, which is written as 1 divided by k minus 2 to power 4, and k starts from 5, goes to infinity. Very good. Let us apply two different methods. What I'm going to do, I'm going to just list the terms of this series. The series 1 divided by k minus 2 to power 4 k starts from 5 to infinity is equal to, if you plug in 5, you get 1 divided by 3 to the 4. If you plug in 6, you get 1 divided by 4 to the 4. If you plug in 7, you get 1 divided by 5 to the 4 and the rest of the terms. So if you compare zeta of 4 and this summation, you basically see some terms are missing. 1 over 1 to the 4th plus 1 over 2 to the 4th are missing. This sum is part of zeta of 4, but missing the first two terms, which are 1 divided by 1 to the 4 plus 1 divided by 2 to the 4. So what are we going to do? We're going to add and subtract these numbers. So let us add, subtract these numbers. So this guy can be written as, here we go, I'm going to write down negative 1 over 1 to the 4th, which is just 1. And for the sake of the pattern, I'm going to write down everything. Minus 1 divided by 2 to the 4 plus 1 over 2 to the 4 plus the rest of the terms of this series, which is 1 over 3 to the 4th plus 1 over 4 to the 4th plus the rest of the terms. So if you group these together, this is negative 1 minus 1 over 16. You get plus 1 over 1 to the 4th plus 1 over 2 to the 4th, 1 over 3 to the 4th, plus 1 over 4 to the 4th, plus the rest of the terms. But this guy, this sum, is nothing but pi to the 4 over 90. So let us copy this guy down here. The summation is negative 17 over 16 plus pi to the 4 over 90. So what is our conclusion? The summation of all of these terms, k minus 2 to power 4, k starts from 5 to infinity, is equal to pi to the 4 over 90 minus 17 divided by 60. So by adding, subtracting some terms, we can basically get zeta of 4. Please note that you can also shift the terms and see the pattern right away. We can also shift the index, use dummy variable to rewrite the series. So our original series is written as the summation of 1 divided by k minus 2 to power 4. K starts from 5, goes to infinity. What I'm going to do, I'm going to introduce a dummy variable, n, and set it equals to k minus 2. So wherever I see k, I'm going to use n plus 2. So when k starts at 5, my n starts at 3. So this guy can be written as the summation of n starting at 3 going to infinity of 1 divided by n to the 4th. Basically, what you have 1 divided by 3 to the 4th plus 1 over 4 to the 4th plus 1 over 5 to the 4th plus the rest of the terms. So basically getting the exact same terms or summation of the series as you plug in k equals to 5. Shifting the index using dummy variables are very useful in combining the series. Shifting the index is very useful in combining series, especially in ordinary differential equation when you find a series solution for a differential equation. So let us recap what we did. By using the zeta function, we know that zeta of 2 is equal to pi squared divided by 6. Also, zeta of 4 is pi to the 4 divided by 90. Students usually memorize these two sums. It's easy to memorize them, not that difficult. And then we use these summation to find the sum of other series. And as we mentioned before, it's a common mistake for students that thinking the integral and the summation result in exactly the same value. It's not. We use integral test to analyze the behavior of the series, not the sum of the series. To find summation, we have other methods to apply. So to find the sum of this series, the summation of 1 over k minus 2 to power 4, if you list the terms of this series, you see a resemblance between these and zeta 4. But two terms are missing. 1 and 1 divided by 2 to 4 are missing. So we basically add and subtract these two terms, combine the rest of the terms, group them together, and since 1 over 1 to the 4th plus 1 over 2 to the 4th plus 1 over 3 to the 4th is nothing but pi to the 4th over 90. We just basically combine these two numbers together. We have negative 17 divided by 16. So the summation of 1 divided by k minus 2 to power 4, k starts from 5 to infinity, is pi to the 4 divided by 90 minus 17 over 16. You could also shift the index using dummy variables to rewrite your series into nicer form. more compact version. Instead of k minus 2, I'm using a dummy variable n. Since k starts at 5, 5 minus 2 is 3, so n starts at 3. So wherever you see k minus 2, write down n, and wherever you see k, write down n plus 2. So n starts from 3, goes to infinity, series 1 over n to 4, and if you list some of the terms, you see you get the exact same terms for this series. Nothing has changed, but this is a very useful technique that we're going to learn.